Hi everybody, welcome to another Matt Black PCs video. Today I'm mostly going to be talking about what's in your computer, such as your tablet, your laptop, your desktop, your cell phone, and other computing devices. So the first thing I want to talk about is the motherboard. Now, the motherboard is known as the spine of the computer because it connects all the components together so they can communicate to each other. Now let's talk about the size of the motherboard, called a form factor. There are four types of form factors: EATX, ATX, Micro ATX, and ITX. ATX stands for Advanced Technology Extended. EATX stands for Extended Advanced Technology Extended. And ITX stands for Information Technology Extended. Now, ATX and Micro ATX are the most common form factors. The ATX is usually a 12-inch by 9-inch motherboard, and a Micro ATX is a 9-inch by 9-inch motherboard. So when matching a motherboard with a desktop chassis, you use the form factor of the motherboard or higher. For example, if you use a Micro ATX motherboard, it can fit in the EATX, an ATX, or a Micro ATX desktop chassis. Now that we got that down, it is time to talk about proprietary versus standardized motherboards. Proprietary means that motherboards are designed specifically for a chassis. For example, let's say you're replacing a motherboard in a laptop, cell phone, a tablet, or some desktops. The replacement motherboard would have to be the same as the original motherboard, while a standardized motherboard can fit into different chassis. Like the example before, a Micro ATX motherboard can fit in a Micro ATX, an ATX, or extended ATX computer chassis. Now let's talk about motherboard specs. Motherboards work with different types of CPUs, or central processing unit, and memory, and will have different sockets to support different type of CPUs and memory. Intel and AMD are the main two brands of CPUs. When picking out motherboards, pay close attention to the CPU socket, because the socket on the motherboard can only support Intel or AMD CPUs of certain generations. So when it comes to memory, we use the DDR, which stands for Double Data Rate Standards. Right now we are on the DDR5. Now we can start talking about buses, or we can move on to buses. Peripheral devices such as keyboard, mouse, printer, and speakers connect to the motherboard to communicate to the CPU. The circuit that connects all this is called a bus, or the circuit that connects all the components and all these peripheral devices to the CPU is called a bus. The bus are used to transfer data, power, timing, and memory addressing to all the components. The motherboard also has expansion slots called PCI Express, or Peripheral Component Interconnect Express. This allows you to add more features to your desktop, such as adding an extra graphics card, a network card, a storage, more USB ports, and more. The PCI Express slots come in different sizes, which are by 1, by 2, by 4, by 8, and by 16. Now, by 1, by 4, and by 16 are the most common. The speeds have increased over time, and every time the speed increases, the speed actually doubles. And the first one was PCI Express 1.0, and now we're already up to PCI Express 5.0. Now let's move on to the firmware and the BIOS. So the BIOS, which stands for Basic Input Output System, or a UEFI, which stands for Unified Extensible Firmware Interface, is the first thing that starts up whenever you power on a computing device. What it does is it just checks all the hardware to make sure everything is working. And then what it does is it conducts a post or a power on self test to make sure that all the hardware is available. And it uses instructions called firmware. But what the power on self test does, it just checks to make sure all the hardware is available and that they're all communicating and easier and they can all read. Now, you can flash the BIOS because the BIOS or UEFI, which is usually the standard nowadays, is the UEFI. But if you hear people talking about the BIOS, then they're talking about UEFI. Um, Now, once again, the UEFI is stored on a ROM or read-only memory, and you can update this BIOS or what is called flashing the BIOS or UEFI, whichever one you prefer. Um, you might have to do this, like let's say you have a motherboard, and that motherboard can support a newer generation CPU. Well, if the motherboard manufacturer or the manufacturer of your laptop, well, let's stick with desktops. If you wanted to upgrade to that newer supporting CPU and you want to do an upgrade, you might have to flash the BIOS in order to install the firmware or the instructions that communicate with that newer CPU. Now, other times you might flash the BIOS because you might have problems with your motherboard, like your hardware is not working right, or you're having problems with the keyboard, or you're having problems with CPU, or you're having problems with RAM. Updating the BIOS can fix hardware problems in some cases. So yeah, that's basically all the BIOS and UEFI and firmware is. Just remember, BIOS is the same thing as UEFI. UEFI is just the newer standard, and it's stored on ROM, which is read-only memory, and it conducts a post or what is called a power on self test. So that's all you need to know about that. Now let's move on to the central processing unit. So now we have made it to the CPU. So let's talk about the CPU. So the CPU, which stands for Central Processing Unit, is responsible for running software, um, firmware, operating systems. Okay, so what the CPU is kind of like the brain. It processes all the data that gets transferred between hardware. So think of this as when you use an input, or when you input something into the computer, the CPU processes that to figure out what you want. So it turns your information into data, and then it communicates to the hardware to get an output. So it pretty much turns your input into information, which is called processing. So it pretty much just turns pretty much your input into data. Now the CPUs run at a speed called gigahertz. Well, it's called hertz, which is how many cycles per second. So 1 hertz is 1 cycle per second. Well, now they run at gigahertz speeds, which is like 2 to 4 gigahertz, and some of them even go even higher. Now, the data that it can transfer is measured in bits. The older processors used to use 32 bits at one time, but now it can process 64 bits per cycle. So That's going to be like the latest standard is the 64 bits. Now, when it comes to the manufacturing, you pretty much have Intel and AMD. These CPUs are made in uh, different grid arrays. The most common grid array is land grid array and pin grid array, or LGA or PGA. LGA is land grid array, PGA is pin grid array. And what this means is in a LGA or land grid array, the pins are on the motherboard and there's little pads on the CPU that when you put the CPU into the motherboard socket, it makes a connection between the pins on the motherboard and the pads on the CPU. And that's how it gets put into the socket on the motherboard. Now, the PGA or the pin grid array means that the pins are on the CPU and the pads are on the motherboard. Now, AMD is the one that uses the PGA, but I think in their newer generations they started using the LGA. And Intel, they use the LGA connections. So that's that. Now, we have another type of processor called an ARM processor, which stands for Advanced RISC Machine. Now, RISC is also an acronym. It's Advanced RISC Instruction Set Computing Machine, or Advanced Reduced Instruction Set Computing Machine. I'm sorry that I got that wrong. I keep saying RISC, but I keep meaning to say Reduced Instruction Set Computing Machine. So ARM stands for Advanced Reduced Instruction Set Computing Machines. And these are the CPUs that are like in your tablets, in your laptops, in your cell phones. Now, these have a different grid array, which is called a ball grid array, or BGA. And the ball grid array is soldered onto the actual motherboard. So the motherboard has pads, and the CPU has little round balls, and they get soldered onto the motherboard. So usually they're not actually are replaceable. Usually, like whenever you get a ball grid array, you usually have to buy the motherboard with the CPU already installed onto it. So on those kind of devices, like your cell phones, your laptops, and your um, tablets and things like that, you have to buy a motherboard with the CPU on there, so they're not really interchangeable. Like you can't change them out. You can't change CPUs on there unless you know how to solder. So now let's go to optimizing CPUs. Now, CPUs have what they call cores. And what these cores are is like having multiple CPUs put um, into one motherboard of the CPU. So in other words, you have a CPU and it has multiple chips on there. And these chips are processors. And they can be 4, 8, 16, or more cores. You can go up 32 cores, 24 cores. And what they do is each core acts like an individual CPU. It can process data or do what the CPU actually does, which is processing information. Now, some of these cores can have what they call multi-threading, to where one core can simultaneously do two processes simultaneously. Like while it's like if one core is waiting to receive instructions from a piece of hardware, it can switch and process data for another um, piece of hardware. So it can process data while it's waiting for other instructions from another piece of hardware. So it can go ahead and process another group of data while it's waiting for another group of data to respond, or waiting for another hardware to respond. so it can do more things out. Now, Intel calls it hyperthreading. AMD calls it simultaneously or simultaneous multi-threading, and Intel calls it hyperthreading. Now, CPUs can have what they call cache memory, and what this is data that is stored in the cache memory. And what this data is data that's going to be used constantly. So you have data that's stored in memory, or what they call RAM, random access memory. And let's say there's instructions that are being used like a lot, like all the time. It's constantly going to be used over and over again. Well, that can get stored in cache, which is on the CPU die or on the CPU, and it can store that memory. And cache memory is faster than RAM. So your most common data that's going to be used a lot is going to be stored in uh, cache memory. Now, CPUs get extremely hot, so they're gonna have a heat sink and thermal paste. And what thermal paste does is it makes the CPU flat, or it fills in where scratches and cuts are at on a CPU, and it makes the CPU flat. So whenever you put the heat sink on top of it, it makes a connection. And what that thermal paste does, it helps. How do you say it? Um, it helps heat transfer to the actual heat sink. So it helps the heat go up into the heat sink to go into the fan to blow out the heat off of your CPU. So that's mainly everything you need to know, or the basics of a CPU. Okay, now we're moving on to memory. So the CPU can calculate, we know this, but the issue is it can't hold, or it can only hold or handle one instruction at a time. So this is where your RAM comes in. So pretty much when you run a program or an operating system, or you're running some kind of application, all the instructions get stored in RAM until you exit out of it or close it. And what the RAM does is it holds all these programs and all these instructions, and then as the CPU needs the instructions, it searches for it or sends data or instructions to the RAM to pull out that data or instruction to process in order for the application to actually work. So it pulls out the instruction it needs to do whatever job that the application is performing. Um, Now, the word RAM stands for Random Access Memory, RAM. Um, Now, one thing about RAM is it is a volatile um, set of memory. So what that means is it only works when the computer is turned on. When the computer is turned off, everything in RAM is erased. This is why you have to have storage drives. Um, so the difference between volatile and non-volatile memory is volatile memory gets erased when the computer is turned on off. So when there is no power going to the memory, a volatile memory, the memory gets erased out of RAM. Now in non-volatile memory, the memory is stored even when there's no power. So that's different. So let's go back to what we was talking about, the RAM and ROM. ROM stands for read only memory. So RAM, once again, is volatile memory. It stores data when the computer is powered on. Um, Read only memory is non-volatile, so it permanently stores data. This is what your, like we talked about earlier, with your firmware is stored on a ROM chip. It stays there as long as there's power. It stays there even when there's not power. So memory can come in different sets of storage. like there's a difference between memory and storage, okay? But there's different um kind of memory. Like you can have 6 gigabytes, 16 gigabytes, 8 gigabytes, 12 gigabytes of memory of RAM. Some go up 32, 64, 128 gigs of RAM. Um, the more RAM you have, the more multitasking you can do on a computer. The more things you can do at one time, or that you can have running all the time. Um, Now, when we look at RAM, RAM is called um, DIMM, DIMM, which stands for Dual Inline Memory Module. It is called this because on the RAM sticks, or the DIMM sticks, there are connectors on both sides of the PCB, or the printed circuit board, or the motherboard that the RAM or the memory chips sit on. And what it is, you have contacts on each side. So for every clock cycle, it can do double the data. That's why it's called double data rate, or DDR. Um, but it has contacts on both sides of there, which is why it's called dual. Then it's called inline memory module because all the memory modules, or all the memory chips, are in line on the motherboard. And once again, it goes to the term double data rate is because it can do two things at one time per clock cycle, or it doubles the amount of data that can be transferred. So that's pretty much it about RAM. Moving on to the GPU, or the graphics processing unit. So every computer has graphic processing unit, because if it didn't, well, you couldn't hook up a monitor to see what your computer's actually doing. So what this is the graphics are used to produce pictures, pretty much, or make video output. So when some CPUs have graphics integrated with them, meaning that the CPU comes with graphics, and what it will do is it will share resources such as RAM, and it will share RAM. So it might store, like, oh, I don't have enough memory in the graphics, so I'm going to use part of the RAM to actually store some of my information to make pictures. Now, what you can do is, if you want to do like gaming or do high-end photoshops, you want to make photos, do that, you might need to buy an enhanced graphics card. So what this is a GPU that you can install into your PCI Express slot by 16, and it can enhance your graphics. It can make your graphics better. It can make it look better. It can process pictures or process videos quicker. So the higher tier you get, the better and faster pictures get. So it can pretty much process a video or process a picture a lot quicker. The better one you get. Now, what these things are is there's a resolution and there's a frame rate. Now, the resolution is pixels. So if you heard like 1920 by 1080, that means you got 1920 pixels going across, while you got 1080 pixels going down. And that's the resolution. Now, the frame rate is measured in hertz, and this tells you how fast a picture can display, or how many pictures per second shows. So if you got a 60 hertz monitor and you're running at graphics at 60 hertz, that means your monitor is refreshing 60 times per second. So it's making a new picture, or it's making 60 pictures in 1 second, or it's just showing how many frames or how many pictures per second. That's what it means. Now, video cards and their GPUs have their own processors and memory in the systems. And so what they do is they have a GPU, which stands for graphics processing unit. These are kind of like CPU cores, but in a graphic card to process images and process videos. And it also has memory, which stores all the instructions to run all these graphics and to run all instructions to build pictures and stuff that you are using on your computer. So, yep, that's basics. So the basics of a graphics card is how fast the GPU is, how much VRAM or memory is on there, what are the frames per second that the graphics card can run, and what kind of connectors like HDMI or display ports are on there, and what is the actual resolution that your graphics card can run. So that's the basics of a GPU. Thanks for watching this video. Um, if you're new, please subscribe, leave a comment, and thank you for watching the video. See you in the next one.